90、89、88、87、86、85、84、83、82、81、180。
打ち上げ3分前です。
3 minutes to launch.
全システムの電源が外部から内部に切り替えられました。
The power has been switched to the internal system.
1段液体水素系準備完了。
We have completed the pressurization of the liquid hydrogen system at its first stage.
150、140、39、38、37、36、35、34、33、32、31、130、29、28、27、26、25、24、23、22、21、120、19、18、17、16、15、14、13、12、11、110、109、108、107、106、105、104、103、102、101、100、99、98、97、96、95、94、93、92、91、90、89、
2段液体酸素系液体水素系準備完了。
Pressurization of the liquid oxygen and hydrogen system at the second stage are complete.
79、78、77、
当地点火。
We are uniting the torch to power the excess hydrogen.
フレームデフレクター冷却開始。
Cooling initiates at the flame deflector at the launch date.
65、64、63、62、61、60、59、
打ち上げ1分前です。
It's 1 minute to launch.
55、54、53、52、51、50、49、48、47、46、45、44、43、42、41、40、39、38、37、36、35、34、33、
ウォーターカーテン散水開始。
At the launch deck, the sound separation water system has been activated.
26、25、24、23、22、21、20、19、18、17、16、
フライトモードオン。
15、
Flight mode on.
移動用電池起動。
Activating the thermal batteries.
全システム準備完了。
All systems are go.
6、5、4、3、
メインエンジンスタート。
We have main engine ignition.
SRB 点火。リフトオフ。
SRB ignition and lift off.
H-IIA ロケット42号機は2020年1月20日午前6時58分14秒に種子島宇宙センターから打ち上げられました。
We have a lift off with H-IIA vehicle number 42 from Jaxa Convention Space Center at 6:58:14 a.m. on July 20, 2020 Japan Standard Time.
打ち上げ以降、ロケットの管制は西延発射管制塔から竹崎総合司令塔に引き継がれています。
Following liftoff, the operation control of the launch vehicle has been switched from the blockhouse to the launch control center.
50、
ロケットは現在徐々に東方向の太平洋上へ飛行しています。
The H-IIA is now flying above Pacific Ocean to the east.
60、
ロケットは正常に飛行中であり、種子島の地上局は正常にロケットの追尾を行っています。
The H-IIA flight is on course, and the Taneshima station is tracking the launch vehicle very well.
80、81、82、83、84、85、86、87、88、89、90。
SRB-A 燃焼終了。
The SRB-As have burned out.
100、110、
SRB-A 分離。
SRB-A separation.
14、15、16、17、18、19、120。
第1段エンジンの燃焼は正常。制御系飛行経路も正常です。ロケットは順調に飛行を続けており、現在の高度は約 95km、秒速約 1.5km です。
The combustion in the first stage engine, attitude control, and trajectory are all nominal. The H-IIA flight is on course. Current altitude is about 95 km, rest is approximately 1.5 km per sec.
衛星フェアリング分離。
The payload fairing jettisoned.
打ち上げ後5分が経過しました。
It's 5 minutes into flight.
ロケットは順調に飛行を続けており、現在の高度は約 170km、秒速約 3km です。
The combustion of the first stage engine, attitude control, and trajectory are all nominal. The H-IIA flight is on course. The current altitude is about 170 km, rest is approximately 3 km per sec.
第1段エンジン燃焼停止。
The first stage engine cut off.
第1弾、第2弾ロケット分離。
Separation of the first and second stages.
第2弾エンジン第1回燃焼開始。
Starting the second stage engine ignition for the first time.
ロケットは現在安定して飛行を続けています。
The status of the H-IIA is nominal.
打ち上げ後9分が経過しました。
It's 9 minutes into flight.
第2弾エンジンの燃焼は正常、制御系飛行経路も正常であり、ロケットは現在安定した飛行を続けております。現在の高度は約 250km、秒速約 6.3km です。
The combustion on the second stage engine, attitude control, and trajectory are all nominal. The H-IIA flight is on course. Current altitude is about 250 km. Velocity is approximately 6.3 km per sec.
ロケットは順調に飛行しております。ロケットは種子島内之浦の各地上局からの捕捉範囲を離れ、小笠原局から追尾されています。
The H-IIA is in good shape. The launch vehicle has flown beyond the range of the Jaxa Tanegashima and Uchinoro stations and into the Ogasawara station.
第2弾エンジン燃焼停止。
The second stage engine cut off.
ロケットはこのまま完成飛行を続け、まもなく小笠原局の捕捉範囲を離れます。
We are at the coast face now. The launch vehicle is shortly flying beyond the range of the Ogasawara station.
この後、打ち上げから約56分後に UAE 火星探査機ホープの分離を予定しています。次のイベントまで一旦実況放送を中断いたします。
Separation of the Emirates Mars mission Hope probe will occur in about 56 minutes into launch. Until the next major event, there will be an intermission.
竹崎総合司令塔からの実況放送は午前7時43分頃に再開を予定しております。
This live coverage will resume at 7:43 a.m. Japan Standard Time.
ここで UAE が目指す火星探査計画についての映像をご覧ください。
The Emirates Mars mission is an inspiring project for us. We use this project to inspire our young people, especially people in the region. Through this project, we learned a lot. We gained confidence. We engaged with the international space community, especially in space exploration and space science. This mission has a noble goal: to serve humanity. The data that will come from Mars through this probe will be shared with more than 200 institutions and universities across the world. This is UAE gift to the world. We are proud to work closely with our strategic partners, especially here in Japan, Jaxa, H-IIA. We will celebrate together the successful launch of our Hope probe to Mars. Thank you.
The Emirates Mars mission had a lot of challenges since the day it was announced till today. There are technical challenges, but there are also certain administrative challenges. When you look at the time frame that was set for the mission, it was very, very challenging. 6 years compared to other nations that have 10 to 12 years to deliver such missions. The other challenge that we had was the launch. We have to launch in summer 2020 if we want to reach Mars before the 2nd of December 2021. Any mistake, any delay in the launch, we'll have to wait for 2 years. The other challenge that we have also is the cruise phase, in which we transfer the spacecraft from Earth to Mars in a 7-month journey. Any mistake happens during that phase, we lose our mission. And then when we reach Mars, there's another challenge. It's the Mars orbit insertion, in which we have to slow down the spacecraft from 121,000 kilometers per hour down to 18,000 kilometers per hour. We go too slow, we crash on Mars. We go too fast, we skip Mars, and we lose our mission. Once we succeed in reaching Mars's orbit, we'll have to transfer from capture orbit to the science orbit. That by itself is a challenge. And then we'll have to collect data, analyze the data, and come up with new findings about Mars, and announce it by the 2nd of December 2021. The Emirates Mars mission is the message of hope to the Arab youth. If a young nation like the UAE is able to reach Mars in less than 50 years, then we can do much more as a region. The same way we used to generate knowledge in the past, we can generate knowledge today and in the future to serve humanity.
この後は三菱重工業製作の映像をご覧ください。
In the infinite beauty of the universe, satellites, space probes, the International Space Station. Even at this moment, various spacecraft are contributing to our daily lives, and they are able to do so only with the forceful guidance provided by rockets.
5、4、3、2、1。
The body of a rocket is made of very thin sheets, only 17 millimeters thick. To reach outer space, the body must be light yet sturdy. The sheets are cut into a special shape called an isogrid structure, approximately 2 millimeters thick. This makes the body lighter and stronger at the same time. Next, the sheets are combined to form a cylinder. This becomes the rocket's fuel tank. Rockets, shaped like a long and narrow pencil, are mainly composed of fuel tanks. The fuel tanks are used for two kinds of fuel, liquid hydrogen and liquid oxygen, each contained in separate tanks. In order to reach higher speeds, the rocket is designed with two engine stages, each having two separate tanks. degrees Celsius, which requires the engine to be able to withstand extreme temperature.
Few technologies have impacted manufacturing as rapidly and broadly as 3D printing. Since its debut in the early 1980s, the global market for 3D printing has grown exponentially. Also known today as additive manufacturing, 3D printing can work with a broad range of materials. And 3D printers can produce just about anything you can imagine, from a guitar to a human heart, to even parts for a rocket. Japan is applying this amazing technology to producing parts for the H-3 rocket, the country's next-generation launch vehicle. In order to achieve increased payload capacity and shorter lead times to launch, the H-3 actually has fewer components than its predecessor, the H-IIA. The development and application of 3D printing technology at the manufacturing facility of Mitsubishi Heavy Industries, or MHI, helped make this possible. In the manufacturing process, powdered metal alloy is spread onto the printer's platform and is fused by a laser. The process repeats until the part is completed. 3D printing is more flexible than traditional processing methods. It supports creativity and is ideal for originally crafted precision parts. And 3D printers are space and cost efficient and can significantly help reduce material waste compared to other manufacturing techniques like cutting and grinding. Now, MHI Group has applied its advanced capabilities to the development of its own 3D printing technology. Lambda, developed by MHI Machine Tool, is a direct energy deposition additive manufacturing system that features two world firsts: a monitoring feedback function enabling real-time control, and a local shield function to allow the use of a wider range of materials. The same technology will allow Lambda to work on precision parts that are not only made of unique materials, but are also much larger than what other printers are capable of handling, often required by the aerospace sector. 3D printing's rapid transition from curiosity to powerhouse technology has revolutionized manufacturing and made the future more exciting than ever before.
After assembly, the rocket is transported to the launch site in Tanegashima, located in southern Japan.
Partnerships are key to the fourth industrial revolution. Companies are collaborating to develop the advanced technologies and solutions society needs. These innovations generate new streams of profit and make a sustainable impact on local communities around the world. They bring dreams to life. Brescia, a town with 3,200 years of history, is located in Italy's industrial center. Here, local steelmaker Ori Martin partnered with energy technology company Turboden to install a plant that recycles the steel mill's waste heat into electricity. The process also cuts the mill's CO2 emissions and benefits the bottom line, a dream combination that many energy-intensive industries can apply.
We invested a lot in the last year, especially to reduce noise, to reduce pollution, to reduce emission, and one of the most important projects we had is a recovery project.
Turboden's organic Rankine cycle technology, which generates the electricity, is at the heart of the project.
Most of the projects that we implement are based on a strong relation between our company, the customer, and other technological providers that complement our solution. And the Ori Martin project is a clear example of this.
Thanks to this plan, we can recover the hot fumes from the electrical arc furnace and convert them into energy. We can produce electrical energy compared to the consumption of 700 families.
Half a world away is a family-owned business in the American heartland. Steer Enterprises is a long-time parts supplier to global automakers. The dreams and hard work on which the founder built the business 3 generations ago live on in quality partnerships today. The company chose Mitsubishi Caterpillar Forklift America to provide a fleet of forklifts to optimize its operations.
We always say that we're building our company for generations to come, so our decision making, whether it be purchasing a forklift, purchasing a business line, all of those are thinking 10, 20, 30 years out.
The long-term view is even more crucial in projects outside of the planet. Space has always been a dream destination for humankind, and Japan's new rocket aims to make it even more accessible. The Japan Aerospace Exploration Agency and Mitsubishi Heavy Industries are decades-long partners and are now working together on the H-3, Japan's next-generation rocket. Scheduled to debut in 2020, the H-3 will slash launch preparation lead time and price and build on Japan's world-class launch success rate.
まずこの H-3 ロケットの目的が
The objective of the H-3 is to lower the barriers to space development and utilization. It's very important to make space easier to access for humankind, and we need to make sure Japan always has a means to access space. By making the H-3 rocket less expensive than its predecessors, we aim to reduce the cost of going to space. This will spark robust space development and utilization.
That's a big dream, one that cannot be achieved alone. Engineering partnerships. This is what it takes to move the world forward.
Half a day before the launch, the rocket is transported by a special vehicle to the launch pad, entering final preparations for the countdown to liftoff.
メインエンジン着火。
3、2、1。
リフトオフ。
Approximately 2 minutes after liftoff, solid rocket boosters are jettisoned. About 7 minutes after liftoff, the first stage rocket engine will be jettisoned. From that point, the second stage engine fires. The rocket, now lighter, accelerates its speed in zero-gravity space, ready to release the satellite to the designated orbit. The speed required to place a satellite into orbit is about 8 kilometers per second. At this point, the rocket would only need 1 minute to cover the same distance as a Japanese bullet train could in 3 hours. After the satellite is separated, the rocket's mission is completed. The rocket, taking over a year and a half to manufacture, finishes its short lifetime at 30 minutes after liftoff. Rockets are continually evolving. In anticipation of an ever-evolving state of rocket development, Mitsubishi Heavy Industries is developing its next-generation rocket. With decades worth of technologies and expertise, Mitsubishi Heavy Industries will continue to contribute to humanity through the utilization of space.
When it comes to society's biggest challenges, there are no easy solutions. That's why at MHI Group, we address big issues with the power of global integrated engineering and relentlessly pursue incremental advancement. To take on the growing demand for clean energy, we're pioneering alternative energy sources and cutting emissions from existing ones. We're anticipating the needs of rapidly growing cities through advancements in transportation and sustainability. Our innovations are revolutionizing how goods get to people around the world through digital warehouses and automation technology. We're making it possible for more people to experience the benefits of space technology with our next-gen launch vehicle. And we're building connections to more destinations with a regional jet that offers more space and comfort for passengers. The biggest challenges inspire our greatest innovations. And because we're constantly working to improve, our best never stays our best for long. So there are always even better things ahead.
ではここでロケット搭載カメラの映像をお送りいたします。まもなく RCC の実況が中継される模様です。RCC 実況にバトンタッチしますので、どうぞご覧ください。
種子島宇宙センター竹崎総合司令塔から H-IIA ロケット42号機の打ち上げ実況放送を再開します。
This is a live coverage of H-IIA No.42 from the Taxi Range Control Center at the Jaxa International Space Center.
UAE 火星探査機ホープを搭載した H-IIA ロケット42号機は2020年7月20日午前6時58分14秒に種子島宇宙センターから打ち上げられました。
Earlier at 6:58:14 a.m. Japan Standard Time today, from Tanashima Space Center, the H-IIA No.42 was launched with encapsulating the Emirates Mars mission Hope probe.
ロケットの追尾は再開されており、現在ロケットは完成飛行を続けています。
We have restarted tracking the launch vehicle. The launch vehicle is currently in a coastal state.
まもなく第2段エンジン第2回燃焼開始を予定しております。
We are shortly going through another ignition of the second stage engine.
第2弾エンジン第2回燃焼開始。
Starting the second stage engine ignition for the second time.
第2台のエンジン第2回燃焼停止。
Second stage engine cut off.
Hope 分離。
The hope separation.
ホープは予定された軌道へ向け分離されました。
The Hope has been inserted into orbit.
これをもちまして H-IIA ロケット42号機による UAE 火星探査機ホープの打ち上げの実況放送を終了いたします。
We will now end our live coverage of H-IIA No.42, which deployed the Emirates Mars mission Hope probe.
種子島宇宙センター竹崎総合司令塔よりお伝えしました。ありがとうございました。
We are reporting from Takasaki Range Control Center, the Jaxa Tanegashima Space Center. Thank you very much.
ご覧の通り UAE 火星探査機ホープは予定の軌道に投入されたことを確認いたしました。詳しい情報については三菱重工業のウェブサイト並びに記者会見にて発表いたします。これで本日の打ち上げライブ中継を終了します。ご視聴ありがとうございました。
フライトモードオン。
フライトモードオン。
起動用電池起動。
Activating the thermal batteries.
全システム準備完了。
All systems are go.
メインエンジンスタート。
We have main engine ignition.
SRB 点火。リフト。
SRB ignition and lift off.
H-IIA ロケット42号機は2020年1月20日午前6時58分14秒に種子島宇宙センターから打ち上げられました。
We have a lift off of H-IIA vehicle No.42 from Jaxa Tanegashima Space Center at 6:58:14 a.m. on July 20, 2020 Japan Standard Time.
打ち上げ以降、ロケットの管制は吉野発射管制塔から竹崎総合司令塔に引き継がれています。
Following liftoff, the operation control of the launch vehicle has been switched from the blockhouse to the launch control center. ロケットは現在徐々に東方向の太平洋上へ飛行しています。 The H-IIA is now flying above Pacific Ocean to the east.
ロケットは正常に飛行中であり、種子島の地上局は正常にロケットの追尾を行っています。
The H-IIA flight is on course, and the Tanegashima station is tracking the launch vehicle very well.
80、81、82、83、84、85、86、87、88、89、90。
SRB-A 燃焼終了。
The SRB-As have burned out.
SRB-A 分離。
SRB-A separation.
14、15、16。